Another live stream, and actually the last live stream that I am going to have for this unit in trigonometry. So this is what we're going to cover today is inverse trig functions, and that is going to really be the end of our kind of core, or at least is our content. So then from here on out, we're going to be kind of focusing on preparing for obviously for the test, and then also preparing for our semester exam. So I do also have another live stream, and maybe I might be able to do another one that I like to come up with a semester exam, work over the preparing for this semester exam, like doing a study guide. So I went and created one. I'm just kind of working on the formatting right now to get that prepared. So for those of you that are interested in something like that, that will be another live stream that I'm looking to probably doing either this week or coming up into the weekend. So hey, Trig, hey, R3TR059R, how are you guys doing today? So basically, again, this is another homework assignment that I'm going to work on. So we're just going to work on evaluating trigonometric functions, or the inverse trigonometric functions. We're going to work on composition. We are going to look at evaluating using right triangles, and then we're going to round up here with some multiple choice questions. So I know that some of you guys, if you're on the kind of same schedule that we are in the United States, then you might have an exam coming up. So hopefully, depending on your class, if you've gone through the trigonometry, this will be something that will help you out. However, I will let you guys know, for those of you that are looking in for identities and all that kind of stuff, which is going to come next, we're not going to touch that until 2019. So we're just going to wrap up, worry about exams, and then we'll get onto that. However, I have a ton of videos on identities and everything else so far. So hey, Kabroom and Hermashu, how are you guys doing? I'm glad you are able to watch my videos and you enjoy them. I'm happy to be able to help you out. Tariq, my name is Brian McLogan, and Hermashu, hello from India. Awesome. I'm so glad you guys could join from all over the world. This is awesome. So for what I'm going to do again for this live stream is I'm just going to power my way through these examples, and then obviously we'll go and take a break. If you guys have some questions that you'd like to ask me, then what I'll do is I'll just kind of take a mind break after the first half, and then we'll get back into finishes up to the multiple choice. So this should run roughly around 40 minutes. That's usually how most of my live streams go, and I'm just going to get into it. I'm going to skip some of my explanations that we've already kind of covered in my class. But the main important thing is just kind of understanding what these trigonometric functions are. And again, the important thing is we're talking about functions. So, I spent like a 30-minute lecture really kind of just explaining this process, so therefore my students can complete it on their own rather than just giving them multiple examples. One thing I do think is important, though, for us to have here is an understanding of, let's see here, let's change that, of just the unit circle. So, a lot of times I'm just going to reference values on the unit circle very, very quickly. And then even though I told my students by this stage, you need to know these points on the unit circle, I know that some of you might be coming into these videos and being like, where did he get that value? And that's always the one comment, it's from the unit circle. So let's just go ahead and get these main values in the first quadrant down. So therefore, when I'm referencing them, you kind of know where these come from. And again, from my previous videos, these values come from our special right triangles when we have a hypotenuse of 1. All right, but obviously, if you're in this stage of trying to learn this, then you need to know the unit circle anyways. Pi over 6, that one's pi over 4, pi 3, and then pi halves. All right. Hey, Alhamen, how are you from Nigeria? Awesome. And Sanali asks you, just curious, but do people usually message you on Twitter with homework help? No, not really. I mean, I have a Twitter account. I don't use Twitter that much. From there, I mean, I kind of follow some people on Twitter that I kind of check in, like teachers and kind of stuff like that, and I get some direct messages and stuff like that. But unfortunately, as far as my being able to do a lot of individual help, I'm really kind of limited with my time. So that's why I like to do these live streams, because obviously these are a part, I do this for my students in my class, but it is also an option for me to be able to help students out, when they do have those specific questions that I use these live streams, for that kind of vision. So, I wish I would have. Okay. All right, so let's go ahead and get on to evaluate. And really what we're doing is we're trying to find the exact value. And I didn't write that in there because you could just plug these into your calculator. But my students are going to be taking a test where they're not going to have a calculator. So we're going to have to figure out what exactly the exact value is. So again, just a quick little review, and then I'm going to kind of power my way through these. When we're looking in for the sine inverse function, it's important to understand, what are we looking for? So remember, back in the day, not too long ago, but when we had a triangle, and let's just say this was 30 degrees, when we were trying to find the sine, we would say the sine of 30 degrees, is equal to, and let's just say, 5 and 7. So that's going to be opposite over hypotenuse. But the important thing is it's sine of 30 degrees. So we're always taking the sine of 30 degrees. And you can see here where the inverse function is you're taking the sine inverse of a value, right? This isn't an angle. This is a value. And more specifically, this is a value of a coordinate point on the unit circle, because when we looked at values that were points on the, kind of unit circle, I don't know what this point would be, then we could just go ahead and look at that being the coordinate point. So this would be like a coordinate point, of 5 over 7. So therefore we'd use the, oops, no, it wouldn't be. I don't know what that coordinate point would be. That's 49 minus 25, so that would be 49. So that would be 20 square root of 24, which, geez, oh man, you have to be reduced. All right, I'm kind of getting I'm getting on a tangent that I don't really need to get on. But the important thing I'm trying to understand here is when we're looking for the sine inverse, we're looking for the angle. So when I take the sine inverse, of 5 over 7, and again, this is a really bad example because 5 over 7 is not the sine here of 30 degrees, so I should probably pick some better values. So let's just go ahead and do a quick little, let's just do 5 and 10. That would be better. Okay, let's use 10 because at least that's the correct values. So now when I'm taking sine inverse of 10 degrees, we know that that is equal to, basically what we're looking for is what is the angle? What is the angle that sine inverse of 5 over 10 gives us? And obviously we know that is, in this example, it's going to be 30 degrees. So the reason why I kind of went into that is a lot of times we've got to see what is the angle that produces, square root of 2 over 2 when you take the sine. So basically, we're asking our question, the sine of theta, sine of what angle is equal to the square root of 2 over 2? Okay, so that's what we're asking. We need to find what is theta. That is what this question is asking us. So we look at the unit circle and we see, well, when you take the sine of pi over 4, you get square root of 2 over 2, and that's good. But then we also notice that other points on the unit circle also are going to give us that value. Specifically this value over here, which has the same reference angle, so that's a 3 pi over 4. But the problem with this angle is that it's not in the restrictions. Okay, and so we talked about these restrictions on the domain, because obviously if you take the inverse of a sine graph, it's not 1-to-1. Or if you take the graph of sine, it's not 1-to-1, so therefore we have to restrict the domain. So the domain restrictions, and I'm just going to write these in there because we already talked about it in class, for sine of x and tangent of x are angles that have to be within the first and the fourth quadrant. And then cosine of x is for angles that have to be in the first and the second quadrant. So these are the restrictions. These are the restrictions that we did. So those are the restrictions on the domain. So these are implied restrictions on the domain, so therefore we can use this sine inverse function. So therefore, if I look at these two angles, I say, well, the sine of pi over 4 works and the sine of 3 pi over 4 works. But the only angle that's within the restriction is pi over 4. So the quick answer would have been pi over 4. So there's not two answers. And again, the important thing, when you plug that into your calculator, you're going to get pi over 4 in radians, or you're going to get 45 degrees. Your calculator is not going to give you two answers, right? If you get two answers, it's obviously not a function. And no calculator, when you plug it in, is going to say, oh, here's your two options. Here's your two answers. No, it has to give you, if this is the sine inverse function, you plug in something, you have to get something out, not two different answers. So that's why we have to restrict these domains on the function to be able to apply the inverse function. And again, if you look at like the notes, as far as what is the range of the inverse function, you can see how it is restricted based on these restrictions we're applying. So again, square root of 2 over 2 is the only answer you get on your calculator, and it's the only answer that works. So now in this next one, you can see cosine inverse of negative 1/2, and I'll just write it again. So cosine of what angle is equal to negative 1/2? Well, you can see cosine of positive 1/2 is pi over 3, right? So if we know it's negative, we know that same angle has to now be in the second quadrant or in the third quadrant, right? Because cosine's negative in the second and the third quadrant. But I look at my restriction and I say, oh, it has to be this one, right? It can't be that angle because that's not within the restricted domain of the cosine. So I think if this is pi over 3, the next one over that reflection is going to be 2 pi over 3. And that is your answer. So 2 pi over 3. Now let's look at tangent of negative 1. So again, we know that tangent, remember, tangent of any angle is y over x, right? So tangents are usually kind of difficult because we have to understand it's not just like finding the value, finding the coordinates here. You got to basically understand when you take the y coordinate over the x coordinate, you're going to get this value of negative 1. Now, fortunately, negative 1 is not too bad because you guys can see that square root of 2 over 2, common square root of 2 over 2, like those are exactly the same. So that's going to give you 1, but that's going to give you positive 1. So therefore, I got to think about, well, then which quadrant is going to make it negative? Well, tangent's only negative in the second and the fourth quadrant. So if here is when it would be positive, if I need to get that same angle in the second and the fourth quadrant, then I kind of have two options here. Like, let's look at the restriction. So the angle is restricted within the first and the fourth quadrant, right? And however, it's going to be negative in the second as well as the third quadrant. So people say, well, here, but that doesn't work because that's outside of the restriction of tangent. And they say, okay, well then let's go down here. And even though that gives you the right terminal side, the problem is the angle has to escape the restriction and then come back in. So, sometimes I kind of joke around, like, think about a cage. Like, you are restricted to only work within that restriction. You cannot go outside and then come back in. And if the really nice way to, like, understand why that doesn't work is to look at the graph. Like, if you look at the inverse, if you look at the tangent graph and realize why this angle would not work, it would make a lot of sense. And I use Desmos in my class to kind of explain that. So what we have to do is we have to get to this terminal side. We have to stay at this initial side. So we have to use a coterminal angle. And again, to do that, we're going to have to use a negative coterminal angle. And I'm sorry, not negative. Yeah, a negative coterminal angle of pi over 4, which in this case would be negative pi over 4. All right. Now let's do sine of negative 1. Now, again, sine of negative 1 is basically, again, we're looking for when is the y-coordinate going to be negative 1? Well, I know that point right down there. And again, this is the only work, but I don't want to do this one because, again, my restriction here is within the first and the fourth quadrant. So I have to use the negative version. So instead of 3 pi over 2, I have to use negative pi over 2. Now this one is negative square root of 3. So which relationship gives you would give you just a square root of 3? Forget about the positive negative. Just which one is going to give you a square root of 3? And this is where doing all this examples and practice with the unit circle is so helpful because there's basically two coordinate points. We already did square root of 2 over 2, right? That equals 1. That's easy. But which one of these simplifies to give you square root of 3? And if you did enough of this practice, if you've done a lot of practice here, then you would quickly know that answer. If you have not done enough practice here, then you would probably have to work these out, which is, spending time mathematically, especially if you're taking a test or a quiz, to figure these out. So I'll just show the ratio, but I have done enough of these in my class as well as on these videos that I'd hope you guys would understand what algebraic process I'm using to simplify this to see. So this is going to be, I know, square root of 3 over 3, and this one we reduce to the square root of 3. Okay, and again, that is just going to be multiplying by the reciprocal and rationalizing the denominator. So That's the angle. Now, what angle is that? That is pi over 3. But again, ours is negative. So it's either the negative version in the second quadrant or in the fourth quadrant. I know it has to be in the fourth quadrant. So instead of going pi over 3 up, I'm going to want to go pi over 3 down. So that answer is going to be negative pi over 3. All right, last one. When is cosine of inverse equal to 1? So again, we can just kind of know the quadrant points here. And I say, oh, cosine of 1 is right there. Right? So that's when the x-coordinate is equal to 1. So therefore, that angle is 0. So the next one now is we have composition. And these kind of look a little bit, crazier than what we've previously, worked on. They look a lot more difficult, but really they're not any more difficult than anything else that we've really just did. So just remember, if you have a function like f of x equals, I don't know, x squared, minus 1, and you have another function, g of x equals the square root of x. Well, if I was to do, g of f of x, basically what we're doing is we're just plugging them in. We're plugging one function into the other. So therefore, that would equal x squared minus 1. Now, that's what we did for composition of functions in Chapter 1. We talked about the composition. We talked about identifying the domain from there. Now we're looking into evaluating, and sometimes we did evaluate. Sometimes I'd say, what is f of, 3, right? So therefore, we had to evaluate. And the way that we evaluate, we'd plug the 3 in for the x, right? And then we worked our way inside out. And that's the exact same thing we're going to do here. You're going to work yourself inside out. So you're going to, now you're not plugging in any numbers because we don't need to in this case. That's 9, so that'd be square root of 8, just in case those of you that are curious, that'd be the answer. But here, we don't have any variables here. All I'm trying to remind you of or display to you is work from the inside out. So if we want to find the cosine of negative pi over 4, again, that's negative, right? So we know the cosine of pi over 4 is square root of 2 over 2. And again, I'm just talking from the unit circle that's in my head. So that's square root of 2 over 2, but it's negative, so it has to be in the second and the third quadrant. Cosine is restricted to the second quadrant, so therefore, what is the angle that produces negative pi over 4 that's in the second quadrant? And that's going to be 3 pi over 4. Pi over 4, which is negative square root of 2 over 2, right? Because cosine of pi over 4 is square root of 2 over 2, so therefore in the second quadrant, which is 3 pi over 4, would be negative square root of 2 over 2. So now I have cosine inverse. Jeez, man, I'm so sorry. Let's redo that explanation. Forget it ever happened. Okay. You're evaluating the cosine of negative pi over 4. Negative pi over 4 is down here, right? I was kind of I don't know what I was doing. So here's negative pi over 4. Now, we know that positive pi over 4 is up there, right? So that the cosine of pi over 4 is square root of 2 over 2. So negative pi over 4 is also square root of 2 over 2 because it's to the right of the y-axis, so that's positive. So really what we're trying to figure out is what is the cosine inverse of this gives us positive square root of 2 over 2. Even though it's a negative angle, it's in the fourth quadrant. Cosine is positive, so therefore it's a positive square root of 2 over. And again, we can just look at it. Here's this point. If you take this point down here, it still has a positive x-coordinate, right? So that's why that's positive. Now, the cosine inverse of square root of 2 over 2, so what angle, cosine of what angle gives you square root of 2 over 2? Positive square root of 2 over 2 within the first or the second quadrant. Well, that one's easy. That's just pi over 4. All right, so it looks like it's the same, but they're not always going to be like that. All right, for the next one, I have sine of 2 pi over 3. So let's go ahead and evaluate. Let's go and sketch 2 pi over 3 real quick. So 2 pi over 3 is going to be over there. I figure what is the sine of 2 pi over 3? So that has the same reference angle as pi over 3, which is actually up there. And that point for this one is going to be square root of 3 over 2 comma 1/2. So if it's in the second quadrant, again, sine is still positive, right? It's just a negative square root of 3 over 2 comma 1/2. So therefore, I'm really just trying to find the sine inverse of positive 1/2. And the sine inverse of positive 1/2 is just going to equal pi over 3. Now, I chose two problems that are very similar to each other. They're not always going to work out that case, but hopefully you get the idea of it's not always that, like, even though sine inverse and sine are like inverse functions, like they undo each other, remember that this inverse function of sine, cosine, tangent are restricted. So therefore, it depends on what you're taking the inverse of. All right, last but not least here, I have a cotangent and a tangent. So a lot of times we can work on functions that are not exactly the same here. So in this one, let's go ahead and graph 7 pi over 6. 7 pi over 6 is all the way over here. We see which coordinate point is that on the unit circle. That one is going to be negative square root of 3 over 2, comma 1/2. If I was going to look at the cotangent, now remember cotangent is x over y, right? So we can think about that. That's really the same as over here. And again, remember that's a negative over a negative, right? So it's really, what is the tan inverse of a positive x over y square root of 3 over 2? Square root of 3 over 3. And then we can see in this case, well, the tan inverse of a positive tangent is only restricted in the first and the fourth quadrant. Obviously, if it's negative, it's in the fourth quadrant. If it's positive in the first quadrant, we know square root of 3 over 3 relates to this coordinate point, which also relates to the angle pi over 6. So therefore, that angle is pi over 6. All right, so this is all nice and great when we have points that are on the unit circle, because if you are familiar with the unit circle, then this wasn't too much of a, you just got to, make sure you recall it and not make any little minor mistakes. But something that, kind of quickly trips us up here is when we have points that are not on the unit circle, right? Because if I was like to draw this, or if you think about, sine inverse, remember going back to my original thought here, when we take the sine of an angle, sine of theta is equal to 5 over 10. So, if I'm looking for sine inverse of 5 over 10 equals theta, like, pretend we don't know it's 30 degrees. We know that this is still the opposite over the hypotenuse, and I'm just trying to figure out this theta. So what we're going to want to do here is kind of create a triangle. So basically, again, sine inverse, we're trying to find the value of theta, or of some angle, right? The only thing we know is that we have a negative 2 and a 3. Now, we got to be careful here because you obviously see that direction matters. We don't want to just talk about a floating triangle. So I'm going to correct this in just a second. The important thing I just wanted to see here is but we can use this information. This represents the opposite over the adjacent, or I'm sorry, the hypotenuse. And again, the hypotenuse can't be negative. That's why I made that positive. Now, we're doing the sine inverse, right? And that's where it's really important. You can only take the sine inverse of, basically a triangle in the first quadrant, which I drew, as well as in the second quadrant. So here's our right angles, right? We have two thetas, and they both have a hypotenuse of 3, and negative 2 and negative 2. Obviously, guys, this doesn't make sense if you're talking about it on a coordinate grid here, because when you're looking at there, you can obviously see that, well, going up is not negative, right? So that one doesn't work. Okay, wrong. So here is our triangle, right? So actually, we're going to want to rewrite this. Let me actually just erase that because it's not even close. So basically, our triangle looks like this. And now we're not really finding theta in this case because we don't need to. It just says find the sine inverse, negative 2 and then take the tangent of that. So when I take the sine inverse, right, I'm able to create a triangle that has this information. Well, if I need to take the tangent, that means I need to figure out the adjacent. Well, right now, I have enough information that I can figure out what the adjacent side is. I just need to use good old Pythagorean theorem, and let's just call this x. So then is x squared, plus negative 2 squared. So therefore, I have 9 equals, x squared plus 4. And then I can say x is equal to plus or minus. This, you can think about this as the square root of 5. Subtract 4, take the square root. But again, because now we can see that direction matters, right? Now, obviously, though, if we're going to the right, we're not going to include the negative value. So it's just x equals the square root of 5. So x is going to equal the square root of 5. So the tangent, so the sine inverse gives us the triangle, and then we take the tangent. I'll just put a square root of 5. So that's going to equal a -2 over the square root of 5. Opposite over adjacent, and then we can rationalize the denominator. And boom, there you go. So, check. Awesome. Now, in this next example, we have an x. Now, this is kind of interesting. But again, if you think about this, well, that's the last thing I want to mention. Again, notice how this is not a value on the unit circle. The reason why is because the radius is 3, right? The triangles within the unit circle that we're aware of all have a hypotenuse of 1, so the radius is 1. Obviously, you can see that this is not on the unit circle, so we are forced to kind of be using triangles, okay? The unit circle is just an aid. It's not like eliminating our use of triangles. We just use it as an aid to further do problems a little bit quicker. All right, so in this one, I have sine, cosine inverse of 2 of x. Again, I see that, we can think about this. The cosine of what angle is equal to 2 over x? Well, based on this information, I'm going to draw a triangle. Now, everything's positive, right? Or at least the adjacent and x is positive. So I'm going to work in the first quadrant because obviously it would have to be negative for it to be in the second quadrant. So I don't really need to worry about a coordinate system here, but I will anyways. So this is 2 over x for some angle theta, right? And actually, let's just use a different angle. Let's just use alpha here. Just to kind of change it up, Okay, so again, from this angle though, we don't need to actually solve for x. It's just asking us to evaluate the sine of the cosine inverse. Well, given us the cosine inverse gives us this information. Now we just want to see, well, can we figure out, if I need to find the sine, I need to figure out opposite over adjacent. So I'm just going to call this y. But obviously we just can't create a variable and say, oh, there's y, and just use that in there. We have to define y. Let's define y in terms of x. So to do that, what I'm going to do is I'm going to set up the Pythagorean theorem. So I'll say x squared equals y squared plus 2 squared. So x squared equals y squared plus 4. And now let's go ahead and solve for y. So this will be x squared minus 4 equals y squared, and then y is going to equal the square root of x squared minus 4. And I didn't use plus or minus because I know that it has to be in this first quadrant, so that's why it's going to be positive. So I can define my y variable as the square root of x squared minus 4. So if I need to now find the sine of this, I'm basically just going to take the opposite over the hypotenuse. Square root of x squared minus 4 over x. And there you go. All right, so I'm going to go ahead and take a nice little break here for any of you guys that want to work on some multiple choice questions. I got 4 of them. You guys can take a look at. I will just kind of check in and see if any questions so far on here. Let's see here. Elijah says, do x and y intercepts with y equals in front? I'm not sure exactly of your question, Elijah. So if you could let me know about that, I would be happy. I'll be more happy to elaborate. Super Bowl if I need to transfer. Well, hey man, basically everything I'm doing in this class period so far is, I provide, free as far as videos. So all of my lectures, basically as I'm working through them, only issue is they're kind of delayed. Obviously the homework and quizzes is basically real time. If you're following along with my channel this year, you are going to get the quizzes as well as the tests in real time. We have a quiz coming up this week and then we have a test. So you're going to get everything real time. The only thing I just don't offer for free is these documents, my quizzes, my tests, my homework answers and stuff like that. Just because they take so much time and money for me to be able to get them created. So therefore, that's why I have those available on Patreon and my channel membership. So if you want to support that side, or if you want to get access to them, that's where that's available. But if you just need the content to understand this information and watching the videos like this, then obviously that's what I'm happy to provide for you. Homesick says, what grade do you teach? I teach high school and just pre-calculus this year. So it's my first year only teaching one class, and it's kind of weird. It's a little bit tiring when you teach the same thing over and over and over again so many times, but it is nice because I get to go deep into the curriculum and also spend so much time, creating a lot of these resources, because it is a lot of time that I spend choosing my problems, making up the problems, organizing the problems, working with people that are my editors and doing all that thing to get all these things done. Like, it's a lot of communication to get all this stuff done. And, it's like even once I'm like done with this one unit, like I'm not going to be like teaching anything new until 2019, but automatically I'm looking at like, all right, I have 4 weeks now to like currently prepare, because obviously once I start getting into teaching, you're so busy and so tired. Like it's always just a revolving door. So this has been one of my busiest years, even though I don't really have to do much planning as far as like, what or how I'm going to teach things, because I kind of have that down pat a little bit. But as far as like the organization and structure of these documents and stuff has been a little overwhelming, but I'm getting through it. Can you please make a video about sine, cosine graphs and do some word problems involving those graphs? I don't have any word problems with those graphs. I mean, I don't cover any word problems with the trigonometric graphs, because I basically feel like if you understand the trigonometric functions and their graphs and their characteristics, then the really thing only holding you up is just the word problem. Like, what is it asking for you? But sometimes I have a ton of videos of graphing sine, cosine, tangent, and I just did a live stream. I don't know, maybe last week I covered that. So yeah, definitely. Yeah, last week I covered the reciprocal functions as well as the trig functions. So go and check that out. Let's see. Can you help me solve homework on my own? The dangerous game. Yeah, if you let me know, I'm going to get going into these multiple choice questions here in just a second. But if you want me to kind of cover any of those, I'll be happy to help you out. Ashlyn says, I'm happy, 12 years old and need some assistance. Well, I don't really cover anything below the high school level, but obviously, if you have some questions on here, I will stay after a little bit once I'm done with this homework to help you guys out. But do you actually message you on Twitter? Okay, so I'm back up to there. Do X and yeah, we got that. What's the highest level, Matt, you've taught before? The highest level that I have taught so far has just been calculus. So in my school, we have Calc 1 and Calc 2. We have a awesome Calc 2 teacher, and she's teaching Calc 1 and Calc 2 this year. But then the previous 2 years, I got to teach Calc 1, and I do miss it. So hopefully, next year I'll be able to teach it, just because I like seeing that extension from, I've been teaching pre-calculus for, I think, 7 years now. So it's nice to kind of see how I'm taking the students from the pre-calculus into preparing them for calculus, or seeing a lot of the stuff that we do in calculus and see how that relates to our pre-calculus curriculum. So, and also it's just kind of nice. I mean, obviously you can do so many more things once you start understanding calculus, or, in understanding calculus topics, you start to realize that so many more doors open for you as far as different mathematical operations that, without a calculus background, you are limited, right? For instance, like, physics, like calc-based physics or non-calc-based physics. But not just in that, just I think overall how calculus is so relatable to so many different things that we learn in so many different sectors. I really do kind of miss that, because a lot of pre-calculus, a lot of the stuff is dry, right? Like we're doing sine, I try to do my best to make the trigonometric functions enjoyable, but really you're just doing math. It's like blah, math, right? So calculus, you just kind of get to do these. I think it's just a little bit more interesting of content. So final tomorrow has greatly helped me. Well, awesome, Vino. Best of luck on your exam. And I'm sorry my video for my final did not come out yet for you, but hopefully if you have another final or for calculus, I can help you out from there. All right. So as I know, I don't teach calculus 2, just calculus 1, or at least I have videos on calc 1, but nothing on, just not many carry over to calc 2. All right. So let's get on to the multiple choice. For those of you that have been not caring about me rambling on and just want to get on with the math. So let's go and practice these multiple choice questions. And for the multiple choice, I'm not going to get into much of an explanation, just kind of help you guys with that. And then also, if you guys have some questions on any of those math problems, let me know. I'll maybe answer a couple questions here after I'm done. So this one says cosine inverse of negative square root of 3 over 2. So I'm thinking about when is cosine, I just want to figure out when is cosine of theta, equal to positive square root of 3 over 2, right? What angle gives me that? And I can see, oh, that's pi over 6. But since it's negative, and I know that my restrictions of cosine has to be within the first and the second quadrant, so therefore it has to be a, I don't want to see negative pi over 6 because negative pi over 6, is down there, right? So it has to be this angle, which would be 5 pi over 6, which is answer A. So again, we need to get into the second quadrant to make the cosine point negative. Use a sketch to find the exact value of the expression. So in this case, we have tangent is 4 over 7. Now it's all positive, so we're going to take the as the first quadrant. Okay, and then we'll just create a new angle. Let's use beta. Let's go back to theta. All right, so we have 4 over 7, opposite over adjacent. If I needed to figure out what the hypotenuse is, let's call it r. So r squared equals 4 squared plus 7 squared. R squared equals 16 plus 49. I'm assuming that's 65, which yes it is. So r squared is equal to 65. Therefore, r is equal to the square root of 65. So then what they're asking is the cosine of this, so that's going to be 7 over square root of 65, which when you rationalize the denominator gives you b. Sweet. On what interval is the identity sine inverse of sine of x equal to x? So there's a couple different ways we could kind of look at this. Because, first of all, if I'm taking the inverse, it doesn't really matter actually what this is right here. That's kind of there to really confuse you, because if you're taking the sine inverse, right, of anything, doesn't matter what that is, that the sine inverse is restricted, right? It's restricted. You can only take that inverse between our values of negative pi halves and pi halves. So it doesn't really matter what sine, because sine of x is going to give you, some angle, right? And sine of x is going to give you, sine of x is going to give you some values, anywhere. But the important thing is those angles here need to be within -1 and, the sine inverse needs to be between, sine inverse is going to be between, you know what? I had my perfect definition here. I'm going to come back to that for a second. Let's go back to number 4. Cosine of sine inverse is going to be 1/2. So let's go ahead and figure out. So that is, again, I don't need to create a triangle. You could create a triangle, but we know that the sine inverse here is, so when is sine equal to a positive 1/2? Well, that's going to equal to pi over 3. So basically we're asking ourselves, well, then what is the cosine of pi over 3? And you can see that the cosine of pi over 3 is going to be square root of 3 over, sine inverse of 1/2. Jeez, man, my brain. So when is the sine equal to 1/2? That's the sine is equal to 1/2 at pi over 6. Man, I'm losing myself. So sine inverse of 1/2, that's equal to the angle pi over 6. So really, if I replace this with pi over 6, now I just need to figure out what is the cosine of pi over 6. And the cosine of pi over 6 is square root of 3 over 2. Answer A. Okay. Hey, Denny Den. Happy for you to join and be a member, man. I appreciate it. Awesome to see you back on there. I really do. Hopefully, I will be getting some new documents up there as well today. So for those of you that are not a member or a channel membership, just to kind of let you know what I do is I basically take this document, homework documents, my guided notes, my quizzes, my tests, and provide the blank version as well as the answer version. And therefore, I just provide them every week, usually on Sunday. So therefore, you guys can kind of use those as a reference tool or whatever to help you out with that. So, but by no means, nothing you guys need to be concerned if that's not something you're interested in. If you just like hanging out with the videos and that works for you, then cool. I'm going to keep on doing that. This is just for people that either wish to support me making that content or actually need that content to help them out with their own class. So would you agree that instructor's ability to give concise and coherent math lectures is the key to success on his or her students? Sebastian, yes, I would agree. I would agree that obviously, I mean, people can be successful with having a poor teacher. I mean, because really your education is dependent on you. And especially I think with technology, the way that it is today, you are not dependent on how good your teacher is. And that's the same thing for, back in the day. You got to think like of the history, right? And the history of like education, it was based on if you had access to these certain, scholars or the books, like that is how, that was the only way for you to get an education. And then it kind of, also turned into your access to like being able to go to a school or then now being able to go to a university and so on and so forth. Well, now we live in the age where, majority of people with a internet access are going to be able to access, almost an infinite amount of information to learn from. And my teaching helps, a lot of you, and I'm happy that it does. But I also know that, a lot of my students or people online, like, they don't watch my videos. They're like, I don't like that guy. He doesn't make sense, or he talks too fast, which I know I talk really, really fast, right? But everybody can find a different teacher, but for no longer are we now restricted. No more are we now restricted to, no longer are we going to be restricted I guess, for, if we have a bad teacher that we have to learn only from that teacher, right? We can go out and get access to many, many other people. So I think that's kind of the important things from there. All right, gotta go. See you, Merpa. Have a good rest of your day. Operating the complete guide to trigonometry. Do you use this book for your lessons? No, I do not. So I do not use the Editor's Guide for Trigonometry, but I have looked at some of their books before, and they have some good points. I think from my perspective on some books and something like that, they see that he, a lot of them will focus on like some tips and tricks, which I teach and I help out with as well, because obviously those aspects can be helpful. But in the same respect, I really a lot of times focus on like the understanding. Like, for instance, when we got into, trigonometry, like I didn't show my students how to do any of these problems. I didn't do any of this. All I did was I spent 30 minutes like explaining the understanding of what and why they were about to do. And then I just allowed them to do it. And then I corrected, their mistakes and walked around and answered questions and so on and so forth. So, there's a lot of tips and tricks here that I could easily have probably just like showed my students, hey, here's what you do here. Here's what you do there. And like, they'd be like, okay, great. Like, I understand that. That's easy. But then like, that's how math was a lot for me. And like, if I didn't find like a tip or trick, like, it's like, that's all I'd look for. And the problem with that is, one, you don't really understand anything that you're doing. Two, it's very, very easy to forget what you're doing when the important time comes, like a test or a quizzes. And then the third thing is, when the problem changes, right? Instead of me asking the question like this, like once I ask the question like that, or like this, or not like this, or like that, or like this, like students, they're like, oh crap, like I can't do my trick anymore. So now what do I do? So if you don't understand conceptually what you're doing or why you're doing it, there's little point in doing tips and tricks, right? However, I do tips and tricks because there's, why do we need to rationalize, multiply by the reciprocal, rationalize the denominator every single time here, right? No, we should probably start getting into like, this is this, like, is that, right? Here goes to here, like, oh, divide off the twos, divide off the denominators. Like, we want to do things that are going to make our life easier. But if we don't understand how to go from here to here, the tip and trick is just going to be worthless to us. All right. So I'm going to be taking Calc 1 at my university next semester. This is Vino. What is the best way to ready myself for the information so I don't get overwhelmed? Well, what's the best way? I think I'll give you like a constant like calculus joke. And the calculus joke is like, what do students have the most difficulty on in calculus? the algebra. Like that's where the most mistakes happen, is the algebra. So, you know, if you feel like a lot of the algebra and pre-calculus was easy for you, then I'd probably say you're going to be decently well prepared for calculus. A lot of times, even in my pre-calculus class, a lot of students, they struggle with pre-calculus because even though they got an A or a B in algebra 2, they didn't really learn fundamentally what they're doing. And therefore, when it comes, you know, kind of like going back to that tricks and tips idea, they didn't really understand what they're doing. So therefore, they're basically getting exposed. You're basically getting called out. And then they're like, crap, I got to like relearn this stuff because I actually didn't really learn it. I just did what I need to do well on the quiz or the test. And calculus is the same way. You know, a lot of students, like, I think understanding the basic trig, because obviously we talk about trigonometric functions a lot. So I think understanding a lot of, basic trigonometric concepts, understanding identities, understanding trigonometric identities is helpful. It trips up a lot of students. You know, it's not like a major idea in calculus, but it's one of those like smaller ideas that from pre-calculus can trip up a lot of students. I also think with the basic rules of like logarithms and exponential, and then really understanding your rules of algebra, you know, that we talked about with radicals and, with fractions, like all this stuff, it just, calculus is like, I mean, there's just so many things that just get thrown at you. And it's not like you're learning anything new. Like you are learning something new, but what's I think harder about calculus is not so much like you're learning something new, but now you're learning something new. And then you're also being asked to recall all this information that you previously learned. And I don't think calculus is like when you boil it down, what you're doing is not really that difficult, or that's not where students have trouble with. What they have trouble with is being asked to remember everything they did. So I would just go back and practice. I mean, that's really the best way to prepare yourself, is just practicing a lot of the fundamental stuff. Practice a lot of the fundamental algebraic skills or trigonometry, and exponential and logarithm. Brian, do you have kids? Yes, I have 2 kids. One is up eating and the other one is sleeping right now. So that's why I'm able to come to you from a live stream. And Matthew says, instead of doing homework, I just watch of your YouTube videos and say, well, cool, man. I appreciate it. I like that. Happy to be able to help you out. So, all right, guys. It's been 48 minutes, so I am going to cut this off, but I do want to let you guys know that I will plan on going live again either this week or into the weekend, doing like a final review for for our pre-calculus class. So if you guys have any questions, or if you want me to post anything in particular, working on that, just make sure you guys reach out to me and we will be able to get that done. So there is the information, going through it, and everything. So cool. All right, guys. I hope you guys enjoy the rest of your Sunday. I'm not going to talk any longer to make this go by any quicker. I am just going to sign off.